Hey everyone, in this lesson we are going to be looking at how multiplayer works. Now, you've likely all played multiplayer games before, but how are they functioning under the hood? What is the systems in place for allowing your computer to communicate with another? Well, the simplest way of pretty much laying out how multiplayer works is by looking at the server and client model. This is basically where we have a server which manages the flow of gameplay, updating clients on game events and states. Okay, the server is basically the brain of the multiplayer game or the networking game. This is basically where it manages, like I said, the game state, and it will then update all of the clients on what that current state is. So the client connects to the server and can send/receive data. So the clients are typically what you would know as the players connecting to the server. And it looks a bit like this. So you'd have your big server there, and then you'd have all of the individual clients connected to it. Now, the individual clients are not connected to each other. So, for example, client 1 cannot directly communicate with client 2. Now, they can do this if it is a peer-to-peer type multiplayer game, but since we are going with the dedicated server/client model, they cannot. So if client 1 wants to basically send a message to client 2, they will have to first of all send it through the server. So they'll send a message to the server. That message will likely contain an address to, inform client 2, and then the server can then update client 2. So the server is really the hub of everything when it comes to a multiplayer game. Now, in the case of Unreal and in what we are going to be looking at, there are two distinct types of model that we are going to explore in this lesson, but there is only one that we are going to be using in Unreal. So first of all, some games have the server as a dedicated piece of hardware separated from the players, okay? You may have an idea of a server, a big computer over somewhere on the other side of the world, which is running your games that you're connecting to. That is what you would know as a dedicated server, okay? Nobody is playing on that computer. That is just acting as purely computational power to run the game. Now, this can be a problem as that requires much more initial setup, and especially for us, if we are just starting to get into creating multiplayer games, we probably don't want to have a dedicated piece of hardware as it'll cost a lot of money, it'll take room, it'll take electricity, we'll have to have it connected to the internet, and there's going to be a lot of overhead that you need to manage that way. So what we are going to do is use a model where the server is also a client, okay? And it looks a bit like this. So before we have our server and we have all the clients connecting to it, but with the server client model, we can in fact have the server also acting as a client. And by acting as a client, I mean that is also a player in the game. So basically, if you've played games before where you might create a lobby or create a game, there is a chance that that server is being hosted on your computer. Okay, so you, along with all the other players, are basically on even ground, yet one of those players is hosting the server on their computer. Now, there are pros and cons between these two. First of all, with a dedicated server, these are the best when it comes to games such as MMOs, competitive games, or games with lots of players. Okay, MMOs because, they could have thousands of players at once, and trying to run that on your own personal computer, it's not really going to work out well. And competitive games because if you are running a server on your personal computer, that means that you basically have authority over what goes on in that game. And if the game is competitive, you probably don't want some random player you're matchmaking with being able to decide, okay, you now have this score, okay? As that, of course, is going to ruin the entire competitive nature of the game. And a dedicated server basically allows game companies to have control over their game and only tell the clients or the players what information they need and authenticate everything that comes in. Now, the server client model is really good for casual co-op games, party games, or games with only a handful of players, okay? Because having dedicated servers for all of these things is not necessary, and generally if you're playing co-op games or party games, they are going to be pretty light in terms of performance over a network. You're not dealing with thousands of players, you're dealing with, up to 4 generally. And party games as well, these are things that really your network is also not going to take a hit because If you're playing games with friends or family, they are likely going to be within the same country, state, or neighborhood. So having a high bandwidth networking system, such as you would with a dedicated server, is not really required. So if you have ever played some casual games, they may be multiplayer, they might have 2 to 4, 2 to 6 people. Chances are those games are running a server on whoever's computer started up the game initially. Whereas if you're connecting to a competitive game or a MMO game, that is likely hosted on its own dedicated server, so it can actually power through and manage all of those people and all of those game events. And this server-client model is exactly what we are going to be exploring inside of Unreal. Now, Unreal, of course, has the ability to support dedicated servers as well, but for teaching the basics of multiplayer, it's going to be far easier, and it's going to take far less time for us to go over the server-client model. So that is what we are going to be exploring in this course. Hey everyone, in this lesson we are going to be looking at getting multiplayer finally working inside of our Unreal project, and this is going to be done through a process known as replication. Now, once we have a server and client established, replication is what's going to allow us to basically exchange the game state and position and variables of everything in our game. So replication is basically Unreal's term for synchronizing the game state across the network. This involves creating/destroying actors, moving actors around, synchronizing variables, and synchronizing components. There are also a number of other things it does, but these are the main 4 that we need to worry about. Okay, so pretty much whenever an actor moves around, we can have it automatically set up to move the actor on all the other clients as well. Same thing for when we create a new actor or destroy an actor. Those actions will be synchronized across the multiplayer game for all players to see. So let's jump into Unreal now and have a look at how we can set this up. So here we are inside of Unreal, and the first thing we want to do is go over to our player blueprint. We're going to select our player component right here, and up here in the search bar, I want you to search for replication. Now, replication here, we have a little drop down. This is basically all of the multiplayer settings for our player here. Okay, whenever you see replication in Unreal, that is basically referring to multiplayer synchronization. Now, the main one we want to go down to is where we have the replicates property, and right now it is set to true. So this basically means that when this player is spawned on the server, it will be spawned on all other clients as well. Okay, every single object or every single actor that you want to be synchronized across the network, you want to basically enable replicate on that. Otherwise, they will only appear on one computer. Now, you don't want to do this for your environment unless it's going to be changing, because the environment is going to be loaded in on all players' computers and it's generally going to be static, so setting that to replicate is a bit wasteful in that way, okay? Only dynamic objects that are going to move around or are going to spawn should be set to replicate. So, since we are set to replicate, this means that our player is ready to be loaded up in a multiplayer session. You can also see here we have replicate movement enabled as well. This means that whenever the actor is moved around by the server, that movement will be replicated and synchronized across all clients. So how can we actually get this working? Well, let's go back to our level 1. And typically when we want to test out our game, we'd press on the play button right here to load it up inside of the editor. But what Unreal allows us to do is simulate multiple different clients and simulate a server and client relationship. So to do this, we want to click on these 3 little dots right here, and we want to go down to where we have net mode, and right now it is set as play standalone. So this is pretty much just a single player client. But if we go down to play as listen server, this means that our main window here is going to be a server. Okay, and if we press play again, nothing else is going to happen. It's going to stay the same, but it is acting as a server then. So it is basically executing this as a server. But we want to test with multiple people. How do we do that? Well, if we click on those 3 dots again, you'll see down here where it says number of players. And right now it is set to 1. And what we can do is set that to be 2. Now when we press play, it is going to load up our game here. And also in another window, it is going to load up our basically our player 2 right here. So you can see here on player 2, I can move them around, and on our main window here, it is actually been synchronized, which is pretty cool, okay? We can move, we can jump. You may notice that the camera is a bit buggy. It's not really loading in the camera properly. We'll fix that in just a second. And if we then go over to our main window here, we can also move around here. It's not really visible since the other window was basically tabbed out, but if we tab back into that, you can see that the player's position is going to be updated. So that's great. This is basically multiplayer working inside of Unreal. And like I mentioned before, multiplayer is kind of already baked into the engine with all that replication, so we don't really have to do much behind the scenes work in getting our players to sync up together, as that is kind of already happening right here. Now, we need to fix that camera issue because right now, player 2, their camera is not connecting properly. So to fix this issue, what we're going to do is we are going to go over to our player controller main here, and we want to basically go to the details panel and search for camera. Because what is happening right now is there's a bit of miscommunication with the server and the clients, basically where the camera is setting its view target, but then it is resetting it to be the default, which is that little camera on top of their heads. So after you search for camera, we want to go down to where we have auto manage active camera target and disable that. So compile, save, go back to our main level, press play, and now you should see that both players are spawning correctly, okay? And the cameras are being set up in the way that they should. So as you can see, when I move left and right here on the client, it is being visible on the other one as well. And in fact, let's also do another test. Let's test it out with 3 players. So we can bump that number up to 3, press play, and now you can see here we will have, if I just drag it over, we have 3 different windows here displaying our players. Okay, but there's one thing you may notice, and that is the fact that there are only 2 players in the game currently, okay? Player 3 on the left-hand side here does not actually have a player controller for us to move around, and the reason why is because it was never created in the first place, and the reason why is because all of our players are spawning on the exact same position here, and if our players are spawning on the exact same position and they have collision enabled, then what's happening is basically the engine is unable to spawn in that player because there are too many things overlapping each other. So what we need to do is set up multiple player start points. So I'm going to drag this one over here, I'm going to duplicate it, move it over here, create another one over here, and maybe then also another one over here. So we have 4 possible player starts to choose from. Now when we press play, all of our players will spawn at their own start position, and we now have all 3 players visible on screen here. Okay, but for testing purposes, I'm just going to switch this back to 2 players just because that's a bit easier to manage. Okay, and as you can see, our players are spawning at different locations right here. So that's great. Now, the next step is going to involve looking at how exactly the multiplayer in Unreal works. Okay, what do the clients know? What do the servers know? What information is hidden from the others? Okay, so in the next lesson, we'll be exploring that. Okay, now when it comes to multiplayer, it's very important to know who controls what inside of Unreal. And by this, I mean the server and the clients don't all have the exact same scope or view of the game as you may think. So, basically, like I said, the server and client do not have access to the same information. So now let's go through all the different things that differ. So, first of all, the game mode. Okay, this is generally where we set up which player pawn we want to spawn, which default blueprints we want to set up, as well as a lot of the overall game logic, such as the scoring and stuff like that. That is only visible on the server, okay? So if you have a game mode and you need your clients to access it, they can't, okay? Because the game mode is not available on the clients. And this is just due to, safety reasons, okay? You might want to have authentication on your game mode. You might want to have the game mode where it might determine, if a player's score is correct or not. And you don't want that being able to run on the clients. You only want that running on the server. Now, when it comes to player controllers, this one is a bit more complex. Basically, the server has access to all player controllers, okay? So let's just say there are 3 players. You have the server, client 1, and client 2. The server has access to its own player controller. It has access to client 1 and client 2's player controllers. And for you, the client, you only have access to your own local player controller. So client 1 only has access to client 1, client 2 only has access to client 2. And this is just so, like before, you cannot have one client interfering with another player's player controller, whereas the server, since they have authority over everything, they have access to everything. Now, when it comes to the player pawns, the server and all clients have access, okay? And this is kind of important because you need to be able to actually see the physical representation of the player in game. Otherwise, everyone will be invisible but to you and the server. So the server has access to every player pawn, so does every single client themselves. So this is why you shouldn't really be managing a lot of the overall game state information inside of the player pawns, rather do that in the game mode or in the individual player controllers. Now, the next one is going to be game state. Now, if you don't know what a game state is, that is because it's kind of a more obscure feature inside of Unreal that's really only used in multiplayer games. And the reason why is because the game state sort of acts as a game mode, but for everyone to see, okay? The game state is what you would use to basically keep track of the overall game progress, the overall score. For example, if you have a game where there is a time limit, the game state is where you would generally have that time limit be replicated across the server, okay, so that everyone can have access to it. Basically, it's like a game mode, but it contains the game state, it contains a lot of the game variables and properties. If you have a multiplayer game, this is where you might want to keep track of the current round, the current scores, just so that everyone can see what it is and maybe update it on their UI. Now, we also have a player state blueprint, which is something we are actually going to be implementing inside of our game here. And the player state is basically the player controller, but visible to everyone, okay? Or it's not like the player controller, but it is basically an abstract representation of the player's data that everyone in the server can see. So this is where you would store stuff such as the player score, maybe the player's name tag, and this is just information that you want everyone on the server to know about the player, whereas the game state is information that you want everyone on the server to know about the game. So yeah, these are just a number of different things, and you can see how they each have different sort of visibility levels. The server, of course, can see everything, but if you as a client don't have access to everything, as a client, you only have access to your own player controller, everyone else's pawn, everyone else's game state, and everyone else's player state, okay? So the main two things I would say would be the game mode and the player controller. Only the server has access to the game mode, so do keep that in mind when you are creating your logic in the game mode and setting up functions that you might want other players to call. Do know that only the server can call functions and events inside the game mode. And when it comes to player controller, don't try and have multiple players trying to communicate with each other's player controllers, as that's not really going to work out in multiplayer. If you want to send a message from one client to another via their player controllers, then you might need to go through the server first, okay, sending a message to the server, which then sends one down to the other player's player controller. Or just try and skip that as a whole and don't try and communicate between client to client, player controller to player controller. Now, a term that we do also need to know is the idea of a local player. On your machine, on your computer, on your console, you are known as the local player, okay? So technically everyone is a local player, but to you, you are the local player and everyone else is a remote player, okay? And your player controller is known as your local player controller. So what we can do is inside of the nodes, we can use the isLocalPlayerController node, which is going to return true if it is and false if it is not. So only for you will it return true. For the server, it is going to return false, because if the server is looking at another player's player controller, that's not their local one. That is a remote player controller. Another thing we want to look at is authority, okay? Authority is going to pop up every now and then, and having network authority basically means you have control over the network, okay? Or essentially, you are the server. So the server has authority, whereas the clients do not have authority. And this is basically something you might want to check. So for example, if you have a player pawn, for example, moving around, every single player on that server has access to its node graph and its events. So when, for example, a player pawn hits an object and you want to detect a collision event, that collision event is going to be called on every single person's computer. But you probably don't want every single person running logic based on that hit event. You only want the server to detect that event. And in that case, you would probably plug that into a switch has authority node, which allows you to basically check to see if the person who is running that node has authority or not. And if they do, you can then do something, and if they do not, you can do something else. Okay, so authority is something that is going to pop up multiple times when you're creating multiplayer games, and it's just important to know that you can use this when you only want the server to execute something and not everyone else. So that is a look at who controls what inside of multiplayer games with Unreal. Thank you for watching. Hey everyone, in this lesson we are going to be looking at RPCs inside of Unreal Multiplayer. Now what an RPC is it stands for Remote Procedure Call, and this is basically a function that we can call on our local machine but execute it on another machine. Okay, so for example, the server can call a function but have it execute on one of the client's computers. Now this is very handy if you want to basically exchange information or have a certain event execute on another client's computer or a server. Now there are three types of RPCs we can do inside of Unreal. The first one is server to client, so this is if the server wants to execute a function on the client's computer. It can also go the other way around, so for example the client can call an RPC on the server's computer. And then we also have the ability for the server to execute an RPC on all clients' computers, okay? So for example, if maybe we want to change the time of day, maybe at one point in the game we want to make it nighttime, well, the server can basically call a set nighttime function on every player's computer, and that will then synchronize the game state that way. Now let's jump into Unreal and have a look at a bit of an example. So here in our game, we can press play like before, we can move around, we can jump, we can do everything. Now, we have not yet used any RPCs because everything is controlled by replication, okay? The player movement, those variables are controlled by replicating those values across the network. Same thing for jumping, that is basically just synchronizing our position. But let's just say whenever we press the maybe the player might press the P key, and that is then going to perhaps increase their size. Okay, maybe that's going to bump up their scale a bit. So let's set that up. So what we would do is we'll go to our player blueprint right here, and inside of our player blueprint, we want to right click, and we just want to search for P event. There we go, P. So now when we press the P key, we can have something happen. Now let's plug this first of all into a print node. Okay, just to see what happens. Okay, so right now when we press P, it is going to say hello. So we can save that, compile and press play. Now on our client here, if I press the P key, you'll see it prints out a message on the top left, but we also see it on the server, and that is because the way that these nodes work is basically when we are printing a message, it gets printed on all clients on the network, okay? And you can see before it, we have sort of our name, okay? So the screen on the right, which is what I'm controlling at the moment, is known as client 0. And if I were to go over to the one on the right here and press P, you'll see that this is known as the server. So we have the server who can send messages like that, and we have the client 0 who is sending like that. Now, what you'll notice is that that code, when I press P, it's not running on the server, okay? And that is because this input event, these only get ran locally, okay? Even though the server has access to our player blueprint here and it's able to run all of these nodes, this event only gets called locally on whoever controls this player. And that is because we don't want multiple people fighting over control for the same actor. So when I press P, it is calling this string. But let's replace this with something else. Let's make it increase the scale of our player. I'm going to create a node here called set scale, and if we scroll down, we should see set actor relative scale 3D. We're going to plug this into the press key. Now we want to add to our scale, so we then need to get actor relative scale 3D, plug this into an add node, and this add node is maybe just going to increase our scale by 0.2 every time we press P. So now, if we save this, compile and press play, if we go to the screen on the right and I press P, what you'll notice is that our player, which is on the bottom, it is going to increase in size, okay? It is bugging out a bit just because the collider is probably not scaling correctly, but as you can see, it's increasing in size. But something you'll also notice is that on the server, it is not increasing in size. Now, if we hop over to the server screen here and press P, you'll see that the server its player is increasing in size, whereas on the client, it is not changing. Now, it is appearing in the air. That's just because the collider is changing size and our position is changing then, so that is still being synced over, but the scale is not. So how can we set this up so that the scale is, it's going to look the same across the network? Well, this is where an RPC is going to come into play. So what I'm going to do is I am going to create a custom event here, and the exact same thing works for functions as well. So I'm going to create a new custom event called increase scale. Now this increase scale event, what we're going to do is we're going to select it and we're going to give it an input. So here we're just going to call this increase amount, and this is going to be type vector. And we pretty much then want to just copy and paste these nodes over, plug that in like so, and set the increase amount like that. So now when the increase scale event is called, it is going to increase our scale by the given amount here. And then when we press P, what we're going to do is we are going to call the increase scale event, and we can send over the increase amount of 0.2 on all axes. Okay, so there we go. Now if we compile that and press play, you'll notice first of all that we have the exact same issue, okay? We're increasing the scale on the local computer, on the local screen, but on all other clients and the server, it is not being updated. Now, the reason why is because we actually haven't created an RPC just yet. We've created a custom event, but we need to basically enable the ability to turn it into an RPC. Now, to do this, we want to select our custom event, go to the details panel, and you'll see here where we have replicates. And remember that replicate keyword, that basically means it is synchronizing the game state across the network. So you'll see right now it is set to not replicated. This basically means that when we call this, it is only going to be called on the local machine. So if the server calls this event, it's only going to be called on the server. If client 0 calls this event, it's only going to be called on client 0's computer. Now, if we click on that, you'll see we have 4 different options. We have not replicated, which is basically what we have right now. We have multicast, which basically means that the server will call this event on all other players' computers. We then have run on server, which is when the client calls this event and it runs on the server. And then we have run on owning client, which is when the server calls this event to run on whatever client owns this object, which would be the local client. What we want to do is basically have our client call this event on the server, okay? Because we want the server to be able to recognize that this is happening. So we are going to click run on server. And you'll notice here on the event, it now says executes on server. So this event is only ever now going to run on the server, okay? When we press P, we are not going to be running this event. The server is going to be running this event. So let's compile that. Let's save and press play. Now on the client here, if I press P, you'll notice that we increase the size on the server, but now we don't increase the size on the client. And that, like I said, is because we are calling this on the server. So only the server is increasing the scale, whereas the client, it doesn't know what's going on. It doesn't know that our scale is changing. So what we need to do then is create another custom event which the server can call on all other clients. So here what we're going to do is we're going to create a custom event, and this one is going to be called increase scale client. And we can actually rename the first one here to make a bit more sense. We'll call this one increase scale server to basically tell us that, okay, this has been called on the server. Increase scale client is then going to take this logic here and plug everything in like so. We're going to add a new input. This one is going to be called the increase amount. And we then want to plug this in here. Okay. Now, what we then want to do is we want to delete this server, so the server isn't actually doing anything. Instead, the server is going to call the increase scale client, sending over the increase amount. And on the increase scale client, we want this event to be called on every client. So we're going to change the replicates from not replicated to multicast. And this now means that the server is going to call this on everyone's computer, so everyone will see it. Nope, we just have to remake this real quick. So we'll go increase scale client, plug that in, there we go. All right, we'll save that, compile it, press play. And now if we go to our client here and press P, you'll see it increases on all clients. Even if we add in multiple players, so let's say we add in 3 players and press play, you'll notice that if I move up here and press P, it is going to increase on every client. So basically what we're doing here is on our local computer, we are pressing P, which we are then telling the server to call this event. On the server, this event here is being called, and the server is then calling this event, the increased scale client, on everyone's computer. So you can sort of see how it's a back and forth, okay? We can't communicate to every client as a client, but we can communicate to the server, and the server can communicate to us. So we are sort of sending a message to the server to tell everyone else. And that is what you can do with RPCs inside of Unreal.